Hey guys, so in this new tutorial, I wanted to actually segue into using Blender. Now, as some of you guys may know, Redshift has been developing a Blender plugin for quite some time now. It is still not available to the public, but I decided that I should probably start making a couple basic introductory videos so that once this is available for people to start using, they'll have some tutorials and references to kind of just dive right in. Um, a lot of people, myself included, will have a background in other applications. So I used to be a Maya user mostly, and then I moved to Houdini. And I've been wanting to pick up Blender just as an extra tool since it's free. The Redshift plugin includes all the plugins for all the applications. So even though I will be using Houdini most of the time, it's pretty useful and neat that I could use Blender for Redshift also as part of being a Redshift license holder. So anyways, the Redshift plugin is a plugin, so it's not a specialized Blender build. So you will be able to just download any of the Blender builds and work with them. Right now, I am using the stable release, so 2.83, but it does work with 2.9. So just a heads up. Once it obviously starts releasing and rolling out, there'll be more information regarding that. Some of the things I'm going to show you guys in this first video series obviously are subject to change since the plugin is still in development. This first tutorial, I'm just going to kind of go over some of the basics for people that are coming from other applications and want to use Blender for Redshift. Now, if you want to start using Blender, obviously you need to download Blender. So you could head over to the Blender Foundation page. And here under the download section, there's the LTS section, which means this is the long-term support. So right now we're 2.83 is long-term support, but you can, like I said, use the newer builds. And actually there's a newer build that I should start using, 2.832, but I'm using 2.831 right now. But anyways, I'll update later. So yeah, once you start, you'll open up Blender, you'll have that splash screen. It will give you an option to use different navigation controls. Now, me being a user of Maya and Houdini, I prefer the industry compatible controls. By default, Blender uses its own navigation and hotkey system. And so when you open up the preferences up here, where was it? Under the Edit tab, there's this little preferences section. And so in case you missed the splash screen options to change that, you can come into here and under the navigation key map, this section, this little tab here, this is the default Blender system. I personally like using the Alt key to navigate and WER to switch between transform, rotation, move. So I switch this, but if you're used to Blender, the traditional Blender hotkey system, then stick to that. I like the industry compatible options, and this just feels more comfortable to me since I use Houdini and Maya, and so my muscle memory is used to those hotkeys. So I have that switched over, but if you're coming from those applications, this is something you might want to look at so you're a little more comfortable. And yeah, once we have that set, our hotkeys will now work with the usual Alt, W for moving stuff around, E to rotate, R to scale, and so on. So that's the basic setup. But to install Redshift, right now at least, we have to manually install the add-on. I'm not sure if once the plugin releases, when it's packaged up with the installer, if it'll automatically place it into the right location, but I think you'll still have to manually update it. So I'll show you guys how to do, or not update it, but turn it on. So I'll show you guys how to do that right now. And let me just undo all that. So again, under the preferences, there's this tab called add-ons. And so the way this works is you can search for add-ons to activate, or install. I already have Redshift installed, but if you were to click this, you will get this UI here, and you could search for the zip file and click install. So like I said, I've already done that, so now it's in this list. So if I search Redshift, you'll see that we have this Redshift add-on tab, and so it's got information like where it is located, where it installs, the devs, the version that you're using, and obviously it's still under development. And so you will need to check this on to activate it. Or if you want to completely delete it, if for some reason your install got corrupted or something, you can click remove and then reinstall. And so once you activate the Redshift plugin, you will need to close Blender completely and reopen Blender so that it is now active. So some other things to keep in mind. Now, once, for example, we do have our setup going, all our lights are underneath our add menu. If you check here, you'll see that we have our lights section, and you'll see we've got our Redshift lights, but they're grayed out. And the reason is because right now, when you first open a brand new scene, Blender itself is going to be using Eevee and cycles, and Blender is not the active render engine. So to switch to the active render engine, on this left side here, you have these panel options. So you need to switch here to the this little camera looking icon, and here under the render engine, you have Eevee, Workbench, Cycles, and Redshift. So you're going to want to switch to Redshift mode. And what this will do is now all our nodes and lights will now be Redshift context. So you could activate all those options now. So if we come up to here and we go back down to our light section, you'll see that we now have our Redshift dome light, our physical light, our portal light, our distant light, and IES light. And these are all options we can select now. So if I click area light, it will build our little area light here. And we can switch this over, can rotate it. And you could still just use the typical Blender navigation also that we're used to. And so that's how you add lights. And you guys, if you guys have experience with Redshift, you know each one of these lights does. For now, I'm not going to be covering any of that in detail. I'm just kind of giving you a brief overview of everything. Let's actually add a plane. So if we go to Mesh, let's click Plane. And let's just scale this up. Actually, let's type in a value. And oops, wrong section. Here we go. Scale. Let's do 50 by 50. And let's raise up our little box here. And so when you want to add shaders, you could switch to the different context menus up here, the shading menu, or you could split your windows. So in Blender, if you have your mouse in one of these little corners, you'll see that the target changes to a little X, or not an X, but a cross. So this lets you split your window panel. And up in the upper left corner, the editor type, this is like the context menu. So if you're coming from Houdini, you could think of this as like matte, sops, all that stuff, different contexts. So we want the shader editor. And you'll notice that by default, this scene originally was a cycle scene. So it made the principal BSRDF. We don't want any of this. And so we're going to make a shader for our ground here. And so if you select your ground plane and you come to this right side panel again, and we switch over to this little like sphere with a checker box in it, this is your material properties. So we need to actually make a new material for our ground. So you can see here that we've got this new option. So you can click that. And it right now did make, again, a principled BRDF. We don't want that. And if we hit add node tree, it will automatically make for us our Redshift material and our Redshift output. And so all these parameters open up, they collapse, and just like the properties. And we could change the name of this material group right here where it says material. We could just call this ground. And that is our material group for our ground plane here. And you could add more nodes two ways. You could click on add and you could search for them. You can check here through this list. And you'll see all the usual Redshift nodes, Redshift noise, all the math nodes, the utility nodes, the standard Blender, the material node. But like usual, the material node is the one material to rule them all. It's Redshift's Uber shader, so it lets you do tons of stuff already. You can also hit the tab key and then start typing. So if I wanted, I don't know, the Maxon noise, you start typing Maxon, and now we have our Maxon noise. And again, you've got all your properties and stuff here. You could open up the properties on the side, on this little side panel, and it'll collapse and open up as you need them. And actually, let's start rendering our viewport. So if you come up to the top right here, you'll see that we've got the viewport shading mode. So if we activate this, it will then switch over to rendering our viewport. And yeah, we could turn on some more of those render options in a little bit. Right now, like I said, the ground is one color, so let's change the color. Let's make it something bluish. And let's add a little bit of roughness. .36. And actually, let's maybe use that same blue color, but on the Maxon noise. So let's switch that over here. Select that. Let's select that. And we'll make this a little brighter blue. And we'll plug this into our diffuse input. And we could switch over the type of noise. So the Maxon noise has a bunch of different noise models. Let's just switch over to Aubert for now. And yeah, you guys could see kind of how things are going already. Now on the right side, we have, when we select our light, we could switch the type of light. So area light, point, and so on. The color. We could switch the mode to temperature. We want to use a temperature. So we can warm up the light. Right now, when you first make your scene, there's actually an extra light that comes in the scene when you first start. So you can see that it's right here. This is a standard Blender light. So actually, let's delete this. And now we've just got our original Redshift light that we made earlier. Now, another thing we could do is go into the render options and start activating some things. So if you come back up here to our camera, you'll see that we've got our render. If we want to do a full render, you could hit render, or you could press the F12 key and it will do a render into disk, or a final batch render, I should say. And we have all our usual Redshift options. If you guys, again, have used Redshift, you know all about all the unified sampling, the sample filtering. So we could take this to 3. The clamping. Right now, there is no active denoising, so we're not using optics or Altis yet. This will be available hopefully soon, but it is not available just yet as of me making this video. But the goal is to have all these options available just like all the other packages. Let's go to our GI. Let's activate brute force. The system tab has automatic memory, so that's kind of cool. It does support optics RT also, so that is under the experimental options in the system tab. If you come down here, we have enable optics RT on supported GPUs and enable automatic sampling. I'm going to just turn on automatic sampling so I don't have to really deal with it. So right now, if I were to just hit render, it would render this little shot to disk. So let's just give that a try. And just press render. And it'll pop up a floating window of wherever our camera currently was, because I didn't lock the camera. But you'll see that it works using the standard Blender render view. Eventually, we will be adding support also for the Redshift render view. Right now, it's just using the Blender system. But one of the cool things about having the Blender system, so if we go to render, you can see that we've got our little render here. If we go to compositing, you could actually add the renders that we have. So if we just go to render layers, you'll see that here is our render. And so you could use some of the compositing tools that Blender has built in, which is really cool. Let's go back to our layout here. And so yeah, just you could go back to standard OpenGL, just quickly clicking this. Now we're back to OpenGL instead of using the actual Redshift render. Let's add a dome light. So if we come back up here, go to our light, and we click Redshift Dome Light, it will make our new little dome light up here in the scene collection section. And if we come down here to our light properties, you'll see we've got our dome light options, gamma, exposure, all that stuff, and where to load our texture map and the type of mapping, spherical, hemispherical, mirror ball, angular. And yeah, clicking the open brings us up to open up our ability to load it in. I'm going to just load in this staircase HDR. And so if we now switch over to rendering the viewport, you'll now see that we've got our HDR lighting our ground. And actually we need to add a shader to our cube because right now it does not currently use one. And let's move our light a little further away. So we'll come up here, click to add a node tree. And here we've got our Redshift material. Let's just switch this over to something dark. And let's increase our roughness here. Our HDR is really bright. So let's bring down the exposure using the Redshift photographic exposure controls. So if you come up to these options over here, this little printer output properties section, there are the color management options. So right now it does use the filmic controls, something to keep in mind. And you could change the look. So we could switch to very high contrast, low contrast, medium contrast, adjust the exposure this way. But you can also use Redshift's camera properties. And in order to do that, we actually need a camera. So right now we do not have a camera in our scene. So we could come up to Add, Camera, and this will build us a camera. And when you have your camera select, actually we do have a camera. I just wasn't, I didn't even notice it. So actually let's delete that one. When you have your camera selected, you have your Redshift camera properties here. So we have lens distortion, photographic exposure, and depth of field. And so if we look through our camera, you can go to the View, Camera, Active Camera, and this will look through our current active camera. Or I think there's a hotkey, F4. Yeah, so F4 will do the same thing. And there's also this little camera button over here, which does the same thing. And you can actually lock your view to the camera if you come up to this little button right here. And there's the view. You can use the view lock. So you can lock camera to view. And this means that now if I move around, the view is locked so that my camera follows this view around. And so, yeah, let's make some adjustments to our camera here. So let's have our camera selected, and let's activate the photographic exposure. And let's just do a film ISO of 90, an f-stop of 10. And actually, I just realized that I need to activate the applied at render time setting. So for the IPR, if you notice that it's not updating, like if I just drop the f-stop, it's not doing anything. It's because you need to make sure this gets activated. So now you can see that it's working as expected. So let's do that. Let's add a little bit of vignette. We could do a little bit of black crush. And this HDR is really strong, so I think I'm going to tone down the dome light. Drop it down. Let's just see -1 exposure stop. -2. And this is a little more okay. Let's try -3. Cool. And so yeah, you guys could see that you could just come in here, start adjusting parameters for colors and whatnot. And yeah, to activate depth of field, again, that's an option that we have inside of our camera settings. You can just turn on depth of field, and right now it's super blurry. And so you could add a focus on object. So if I click the cube, now it's focusing on the cube. Let's add a new object into our scene. Let's make a sphere. It's a little UV sphere here. And so you could obviously, like I said, click on different things. So if we've got our camera and we click on, instead of the cube, we'll click on our sphere. Now that's what's in focus. The circle of confusion, this controls how strong our bokeh size is. So higher values obviously means larger bokeh, so much stronger depth of field. We're going to just stick to like a low value. Let's do 0.5. And actually, let's delete our cube. Let's stick to a sphere. We'll scoot this over. And you guys can see how everything goes out of focus behind our little sphere here. And actually, I think that's way too strong, so let's reduce our depth of field. Now, you'll notice that you can see the faceting on our sphere, and that's from the polygons. So we could do to make this smoother is we can subdivide this using render time tessellation. So those options, when you have an object selected, are available inside this little orange box, I believe, in the object properties. You click this and you'll see that we have a section called Redshift. Now this lets you do a lot of things like object ID, tessellation, displacement, visibility, the matte option. So I'll kind of go over these briefly. The object ID, this is useful when working with puzzle mats, stuff like that, to make object IDs. I'm not going to go over AOVs, but I'll go over the tessellation. So this is if you need to do some displacement, you could just activate this. And you'll see that our object is now smooth. Let's zoom in here. And that's because it's subdivided using screen space adaptive, smooth subdivision, and how many times it could subdivide. If you guys want to know exactly what all these options do, I recommend you guys watch my displacement tutorial that kind of covers all this in detail. The parameters are the same in every application. Doesn't matter if you're working in Maya, Blender, Houdini, they all do the same thing. So just give that a watch if you want to know exactly what these options do. We have our displacement here. I don't actually have any displacement shader active, so let's add some displacement onto our little sphere here. Let's select this, go to our material, and actually it doesn't even have a material, so let's build a new material. Click that, and so you'll see that we've got our Redshift material now, and it's shiny. And let's just make this a brightish, orangish, reddish color. Let's switch it to GGX. Let's add a little bit of roughness. Let's rotate that around. And actually, let's switch our filmic. Let's try high contrast. Now, every time right now I move, it has to reprocess our tessellation because it is using adaptive tessellation, which is based on the camera distance to the object. And actually, I could disable that and use world space, which is what I think I'm going to do. So if I have our sphere selected here, we go back to the object properties. And under the tessellation, I disable screen space. And let's only subdivide twice for now. So 2 subdivisions, a 0 minimum edge length. And let's disable screen space. It will only calculate it once, and then it's done. So you'll see that it updates much faster now because it doesn't actually have to recalculate. Screen space is really useful for stills because it's adaptive based on the distance the object is. But during IPR, you might want to freeze the adaptivity, and for animations, you want to use world space also, because the camera moving closer to the object will introduce changes in the displacement because it's adaptive. So let's add some noise here. So let's hit the tab key, start typing Maxon, and we'll get the Maxon noise node. And let's plug this in as a displacement. Let's move this to the side here. Let's zoom out. And let's start typing displacement. We'll get a displacement node. And we're going to plug this output into our texture map input. And we're going to plug the output into our Redshift material output displacement slot. So if we do this, we should start. Oh, and I need to activate displacement. Right now, the object still only has tessellation. So if I click on our object, you'll see that we have now this displacement tab. And we activate this, we should start seeing some displacement. I do need to probably increase the displacement. So let's see what happens if I make this a little larger. Let's try 5. You'll see that now we've got some big blob. And so we could try different noise patterns. If we come over here, let's switch instead of noise. Let's see what Poxo does. And so cool. Now we've got this neat looking weird shape. And this might be a little too strong on the displacement. So let's click our displacement node again. And let's reduce our height. Let's try 1. And that's a little better. Now, something else you can keep in mind regarding the options here for the displacement is that you can also increase the maximum displacement range and the displacement scale on the object itself rather than on the shader level. So if on the shader, for example, I had it set to 0.5 for some reason, let's just make it a little smaller. You can actually increase those values here on the object Redshift parameters in the displacement tab. So if I switch the max displacement to 5, for example, that means that it could reach out much further. And if we increase the displacement scale to 5, you'll see that we've got this much larger shape now poking out. If I were to reduce the max displacement, we'll end up getting clipping. So you'll see that the edges here are getting clipped. And so that's what the max displacement lets you do, and the displacement scale. So this is useful if you're reusing the same shader and you don't want to increase it on a per shader basis. Let's say this shader was on multiple spheres, but you didn't want that same amount of strength on each object. That's what this parameter here on a per object basis kind of lets you do. So if I switch this up to 8, we'll just make this 8 also. We can zoom out a little bit, bring this up. You'll see that it starts making some really cool kind of shapes. And obviously we can increase the subdivision count. So if we do 3 subdivisions, you'll get more high quality shapes inside of your object. And I think something like this would look kind of neat if we added a little bit of subsurface scattering. So let's go back to our material properties and come down to our subsurface. I'm going to use extinction instead of transmittance. And for our extinction coefficient, let's switch this up. And let's use, the way extinction works is it uses the opposite color. So if you want yellow, you're going to want to actually put it in blues. And if you want blues, you're going to want to put it in yellow, and so on. So the opposite of the color wheel is kind of how it works. So let's maybe move it over here. Or let's do some yellows. Let's see. Switch it this way. And let's increase our extinction scale. Let's try 5. And for our scatter scale, let's increase this to 5 also. Let's just see what happens. And so yeah, this is way too much. So let's switch this back down to 1. And our extinction scale back down to 1. It's a little more subtle. That's kind of cool. Got some interesting shapes going on in there. And you could adjust the forward and back scattering by adjusting the phase. So if we want to forward scatter a little more, let's do 0.4. And maybe the extinction scale is a little too high. Let's try 0.25. And reduce our scatter scale also. Neat. And so yeah, I think that's gives you guys a little brief introduction here. So yeah, let's actually try to render this out real quick before wrapping up the video. Let's just move around, kind of find a cool angle. This looks kind of neat. And let's just change the resolution here for our output. So right now it's at 1920 by 1080. And we could let's just do half for now. So half res. And actually on the subsurface scattering here, let me reduce that just a bit. Select our object. Let's reduce our scatter scale. Actually, wrong way. 0.05. And let's just make this like a orange color. Alright, I'm going to save my scene. Hit save. And I think, is the depth of field still on? Should still be on. Let's check here. Yep. Let's increase it a little bit. And yeah, let's render this out and just see kind of what we get. So come up to here and hit the render button. And there we go. Cool. Got our little render here with depth of field, rendered in a couple seconds. And we could obviously clean this up a little more. Right now it's a tad bit noisy. Not super noisy. I mean, we're not using any denoiser. Actually, let's reduce the adaptive error threshold since we're using automatic sampling. You could reduce this to 0.5. And let's just render again. And yeah, got a nice clean render. Cool. So hopefully you guys now kind of understand some of the basics here with Redshift and how to get started rendering some stuff and how to use some displacement and how to bring up shaders and make some lights. I'll be making other videos that are a little more specific to certain aspects of Redshift, but if you're new to Blender, I just recommend you just watch regular Blender tutorials because most of that stuff, minus the shading and render settings, kind of apply to your workflow. So yeah, thanks again, guys, for all the support on YouTube and Patreon. Have a great day.